The U.S. Army is accelerating its modernization of tactical logistics with the recent $89 million order for Oshkosh Defense's Palletized Load System, PLS, A2 trucks, a move that underscores the service's focus on autonomy, digital integration, and operational resilience in contested environments. The purchase, made under the Family of Heavy Tactical Vehicles V, FHTV V, contract through the Army Contracting Command, Detroit Arsenal, is set to support frontline convoy operations while also allowing flexibility for future technology insertions. The FHTV V contract, which extends through August 2029, is not merely a procurement exercise, it reflects a deliberate strategy to maintain fleet readiness while gradually transitioning to more advanced systems capable of operating in increasingly complex theaters of operations. The PLS A2 trucks are designed to retain the traditional heavy tactical truck functionality, particularly the load handling system that enables crews to pick up and set down flat racks or ISO-compatible containers without the need for trailers or external lifting equipment. This capability, which has long defined the PLS family, allows units to execute rapid resupply operations and maintain operational momentum, even under stress. What distinguishes the A2 variant is its integration of autonomy-ready features, active driver assistance systems, and an open digital architecture. These enhancements are not superficial, they fundamentally shift how the Army envisions tactical logistics in an era where supply lines are under constant observation and increasingly vulnerable to disruption. By-wire controls form the technological backbone of the A2, enabling supervised autonomous convoy operations and leader-follower configurations on public roads or other high-risk segments. This capability allows a single-manned lead vehicle to guide unmanned followers, reducing the number of soldiers directly exposed to potential threats while maintaining convoy speed and cohesion. Active driver assistance systems complement this functionality by improving safety in challenging conditions. Features such as adaptive braking, stability controls, and integrated situational sensors mitigate rollover and collision risks when trucks operate at full load over uneven or poorly maintained terrain, under limited visibility, or in inclement weather. These systems not only enhance crew protection but also reduce fatigue, a crucial factor in sustained logistics operations where human endurance often dictates operational tempo. The open architecture of the PLS A2 further ensures long-term relevance and adaptability. By providing a modular digital framework, Oshkosh enables the Army to integrate new autonomy kits, sensors, electronic countermeasures, or protection modules without redesigning the entire vehicle. This design philosophy reflects a broader Army approach that prioritizes technology insertion and platform longevity, allowing units to gradually implement new capabilities as operational needs evolve and regulatory conditions for autonomous vehicles mature. Essentially, the A2 is not just a truck, it is a platform capable of continuous evolution, supporting both present-day operational requirements and future innovations. From a fleet management perspective, the FHTV V contract structure is significant because it blends new production with recapitalization of existing vehicles. This approach allows the Army to field upgraded trucks at scale without waiting for an entirely new fleet to be manufactured. It also helps standardize training, maintenance, and logistical procedures, reducing lifecycle costs and simplifying sustainment planning. For brigades, this means that operational availability is more predictable, and units can plan resupply missions with confidence that trucks will be ready when needed. The ability to integrate both new and upgraded vehicles into operational formations ensures that technological advances do not come at the expense of readiness, a balance that is particularly important in frontline logistics where timing is critical. The operational context driving these investments is equally instructive. Modern military campaigns increasingly involve dispersed formations, extended lines of communication, and high levels of surveillance or interference along critical supply routes. In Europe, dense infrastructure and high visibility make convoys vulnerable to observation and harassment, while in the Indo-Pacific region, extended distances and limited logistical infrastructure impose significant demands on fuel, ammunition, and spare parts resupply. The Army's focus on contested logistics reflects a recognition that future conflicts will likely challenge conventional supply paradigms, and that platform flexibility, survivability, and automation are essential to sustaining operational momentum. The PLS A2's autonomy-ready and active assistance features are thus tactical enablers, reducing both risk and resource burden while increasing responsiveness. The A2's digital integration also has practical implications for operational planning. By incorporating advanced diagnostics, software-managed subsystems, and improved power distribution, the trucks allow for better fault detection, maintenance scheduling, and overall fleet health monitoring. Even units that continue to operate manually benefit from these upgrades, as vehicles remain more reliable, easier to repair, and better equipped to handle the rigors of continuous field operations. The integration of electronic systems does not replace the traditional strengths of the PLS fleet but enhances them, creating a synergy between proven heavy lift capabilities and emerging technological advantages. This combination is particularly valuable when operating under contested or high-intensity conditions where downtime or vehicle failures can directly impact mission success. Strategically, the Army's decision to pursue autonomy-ready logistics platforms reflects broader shifts in national defense priorities. Modern campaigns increasingly involve pacing threats that include long-range strike, maritime denial, and anti-access strategies. These conditions complicate access to ports and distribution networks, making ground-based resupply more complex and potentially hazardous. Trucks capable of autonomous or semi-autonomous operation, with the ability to integrate electronic countermeasures and sensor suites, give commanders multiple options for transporting critical supplies while mitigating risk to personnel. The PLS A2 is designed to be relevant across these diverse scenarios, providing flexibility that extends beyond conventional supply lines. The FHTV V procurement also signals a thoughtful approach to fleet modernization that emphasizes incremental upgrades rather than disruptive overhauls. By recapitalizing older vehicles alongside producing new A2 variants, the Army ensures continuity in operational capability while gradually introducing advanced technology. This strategy avoids the pitfalls of a purely replacement-focused model, where units must wait for an entirely new fleet to be delivered before realizing improvements. For logistical operations, where scale, consistency, and predictability often matter more than headline technology, this approach ensures that the Army can maintain resupply capacity even as it integrates autonomy and other digital enhancements. In addition to operational and strategic benefits, the PLS A2 program also offers insights into the Army's broader technology insertion strategy. The emphasis on open architecture, modular electronics, and autonomy-ready controls aligns with a philosophy that favors adaptable, future-proof systems. Rather than locking commanders into a single configuration or requiring extensive redesigns for every new capability, the Army can upgrade these trucks incrementally, responding to emerging threats, new technologies, or evolving operational concepts. This modularity also supports interoperability with other systems, ensuring that resupply missions can leverage centralized command and control networks and integrate seamlessly with brigade-level or theater-wide logistics planning. The Army's investment in the PLS A2 thus represents a convergence of operational necessity, technological foresight, and strategic adaptation. It acknowledges that modern logistics operations face multiple threats, from observation and disruption to the inherent challenges of long supply lines, while also leveraging the potential of digital and autonomous systems to mitigate those threats. By combining tried-and-true heavy-lift capabilities with cutting-edge electronics, active assistance, and a future-ready design, the PLS A2 embodies a holistic approach to frontline resupply that balances safety, efficiency, and adaptability. Looking forward, the PLS A2 program is likely to influence not only Army logistics doctrine but also the broader landscape of military vehicle development. Platforms that integrate autonomy, digital control, and modular adaptability will increasingly define operational expectations, particularly in contested or high-risk theaters. The Army's incremental approach, mixing recapitalized vehicles with new builds, emphasizing open architecture, and focusing on operational scalability, offers a model for how armed forces can modernize their logistical capabilities without sacrificing readiness. In effect, the PLS A2 is more than a truck, it is a bridge between conventional tactical logistics and the autonomous, networked operations of the future. In conclusion, the $89 million PLS A2 order under the FHTV V contract illustrates the Army's commitment to modernizing its heavy tactical fleet in a measured, forward-looking manner. By integrating autonomy-ready features, active driver assistance, and modular digital systems, the Army is preparing its logistics operations for contested and technologically complex environments. The combination of recapitalization and new production ensures that upgrades are fielded at scale, maintaining readiness while introducing advanced capabilities. Strategically, the PLS A2 supports dispersed operations, reduces exposure of personnel, and aligns with broader defense priorities, ensuring that critical supplies can reach the front lines even under challenging conditions. This procurement is a clear signal that the future of Army logistics will blend proven heavy lift capabilities with the flexibility, safety, and operational efficiency enabled by emerging technologies, setting the stage for more resilient, adaptive, and digitally integrated supply chains in the years ahead.